Hey there, welcome back to the channel. My name is Chris, and today we're going to go back and look at the YoshiBot. So this is a .NET driven rover that I am working on, and the challenge that we've got right now is steering. So let's go take a look at what the problem is and what the solution is. So the challenge with steering a rover, or really any wheeled vehicle, is this. Assume that this is the front of the vehicle here, and then this is kind of the center line of the vehicle. So it extends down, but this is the center line on which it's going to turn. And so if we're turning, let's say that this is our front tire here. If we're turning, it has, a center line of that turn that is somewhere right out here. And so this is a right angle here. This wheel over here can't turn the same amount, because if it turned the same amount and we had therefore the same angle, we'd have a line that was parallel and its center would be here. And so when the vehicle goes to turn, what you'd end up with is either this gets dragged along or this one, understeers. Basically, they're not going to be pointed at the same direction. They have to be on a tangent of this turn radius. So really what has to happen is this one has to have the same center point for the turn. So we have this center point, and then this wheel, I guess it's not really lined up here, but you get the idea. And this needs to be square as well. So if we take a look at, if this is our 0 for our turn angle, this angle here is going to be less than this angle here. So these are not the same, and they will actually change in proportion. So if it's straight ahead, they're both going to be equal. But as you turn, this one, the inside one, is going to rotate to a larger angle than the outside one. So if we're going the other direction, this one ends up turning faster than this one. So you have different angles between the two. This is called Ackermann steering, and these are Ackermann angles. My assumption is that some guy named Ackermann figured this out way back when. One other challenge here is that this is going to be turning on a circle here, right? And we have a center point of the circle here. Well, this one is going to be turning on a circle with the same center point. So to go around a corner, this one has to cover more distance than this one. So not only are the angles different, the speed at which the wheels must spin is different between the two. And again, it is a ratio that is dependent on the angle. If we're going straight, the speed of rotation is the same. But the more we turn, the larger the difference in these angles and the larger the difference in the speed of rotation. So on our vehicle, the rear is super simple, right? They don't turn, so they're fixed, and they're independent, so they can rotate themselves at a different speed. That's no problem. The front is a little bit more of a challenge, but because we have a motor on each one and we can individually control the speed of those, we can deal with that speed ratio difference. And because we have a servo here and a servo here, and we can individually drive the angle for each one, we can also adjust that. When we go to a 6-wheel vehicle, this is going to be really critical because we're going to have these ones steerable and drivable. Then in the middle, we're going to have drivable. They're not going to steer, but they will still have to rotate at different speeds. And then we're going to have another set back here that will also turn, and the turn angles for them will be the reverse, or I guess the mirror of these ones here. So the steering angle will be in this direction and then out this direction on something like this. So let's go take a look at the code that I'm using to calculate this Ackermann angle and the speed ratio, and then we'll take a look at how it's working on this vehicle. What I created was this method here. It's going to calculate the outer wheel from the inner, and it needs two things. We need to know that inner wheel angle, what is the angle that we're going to set for that inner wheel, and we need to know the track width. And the track width is simply the distance from the center line of the inner wheel to the center line of the outer, so the stance of the vehicle. It then goes through and it does some checking of the parameters to make sure that, the track width is not less than or equal to 0 and the angle isn't more than 90, because you can't turn the wheel more than 90 degrees. But then it does some fairly simple calculations. You can see this is all of the math that's involved here. We calculate these angles, and then we calculate, it figures out the inner radius and the outer radius of those two circles we talked about, and then gets you your speed ratio. And then it returns what the angle of the outer wheel should be, and then the ratio between the wheels for speed. The way this is used is really kind of the more interesting thing. What I created was a steerable drive pair, and this is kind of the logical, I guess, aggregation of two motors and two servos. And it allows you to set the steering angle of the left and right, as well as the speed of the left and the right. So what happens if we take a look simply at steer, we tell it what the angle is of the inner wheel we want to use, and it goes through and it calls that Ackermann calculator, and it calculates that angle. And so then it decides, okay, are we turning left or right? And it rotates the two servos. Now, if we rotate the two servos while we're already moving, we have to then adjust the speed as well. So it takes that speed that we got and it recalculates it. And up here, it takes that and it figures out what that speed ratio is, and it speeds up the outer to match what is required to keep up with the inner speed. So the speed that we have set is the speed for the inner wheel, just like the angle is the angle that we want for the inner wheel. And then it calculates how fast and at what angle the outer wheel is. Inner and outer obviously depends on whether we're going left or right. And then, just to test this out, I did create a steering test. So it creates a front drive pair, which again is the logical combination of all four of those things, two motors, two servos. And then it's just going to swing 30 degrees each direction at 50 RPM. And you'll see that the angle between the two is not the same, and the inner and outer are not going at the same rate. The outer wheel always speeds up to catch up with the inner. So let's take a look at what that looks like in practice when it's running. I'll just run the app. It's a .NET app. As it's running, I don't know if it's really obvious the difference in speed, especially with the frame rate of the camera on the phone. But whichever one is on the outside of the corner is definitely speeding up. Another thing that isn't super obvious here is that angle. And the primary reason that this is wrong is I don't think that we have the trim on these correct. So when they start up, they don't start up 100% straight. I need to add some code in there to allow you to set what that 0 is. When it's at 0, this one is turned a little bit. And that's why it seems to be a little bit further. These two servos are also not the same model, which makes it a little bit more deceptive because this one rotates faster than this one. So this one gets into position a bit quicker. You can see how much faster it moves than this one here. You can see that .NET is fully capable of creating a rover. It'll do everything that we need it to do. Right now we have driving, so we have kind of the chassis, the main system for this robot. What we're going to do next is we're probably going to add a camera, maybe some sort of sensors for distance to objects so we don't run into things. Maybe I'll use time of flight, maybe I'll use LiDAR, ultrasonic. Not exactly sure yet exactly what I'm going to use. All of this hardware, the schematics, the software is all open source. I will leave links down in the description to all of that. There's also a Discord channel, so if you're interested or if you have questions, you can post over there, get some assistance. It'll be interesting to see when we start having other people assemble this and put things into it to see what we come up with. At any rate, thanks for watching.